In today's lecture, we're going to start working with variables. We're going to talk about what they are, how you use them, and how you convert between two different types of them. I'm creating a project called Number Doubler. Now, we've already worked with, in a previous application, accepting user input from the form and putting that input back out. If you download the current version of the class code from GitHub, out in the 129.13 folder, there is a project called Input Mirror. And on the button Submit, double-clicking here as a shortcut will take me to the code. We'll see that we actually took our label and we set the value of that label to be what the value of the text box was. And so we kind of have this idea of using a control on the left-hand side of the equal sign and using it on the right-hand side of the equal sign. Depending on what side of the equal sign it is going to determine whether it gets the value, whether it sets the value or whether it gets the value. Anything that's on the left-hand side of the equal sign is going to be receiving the value of whatever's on the right-hand side. So if I were to run this program and I typed in value, for example, and I hit submit, it's going to take the value out of the text box, which is right here, and when I hit submit, it's going to set the value to whatever's over here. Now we're working with text here, but this would work with any data type at all. So I'm going to close this down and go back into the assignment that we're working on today. I'm going to kind of do the standard button, label, and text box. I'm going to pause my video while I get this looking nice. I'm going to align it nice, and I'm going to set the font. Now that I have that looking good, I'm actually going to create another label here. I'm going to copy this label, right-click, copy, and paste. And I'm going to use this to just do a normal piece of text. We don't need to set the name for this because it's going to be a piece of text that we're not going to be accessing via code. So it's okay to leave that as the default. So here I'm going to say enter a number. And then copying it again. Oops. Alright, doubled here. And I can select both of these holding down my shift key and left clicking them, and doing so opens up these options up top. These are my alignment and my layout options. I'm going to align them to the right so that it lines up with our form. I'm also going to copy my submit button and paste that onto the form as well. This one is going to be my exit button. Now I have not named any of these controls yet. Often what I'll do is I'll go out and I'll set my form up, I'll make all my controls look to how they're supposed to look, and then once I kind of have the big picture on how everything looks, I'll go up back and I'll give them their names. So for my text box, I'm going to call it txt number. For my label, I already have the placeholder text, so I will be naming this one LDL message. And this one is easy, btn submit and btn exit. I want to save myself some time. I want to save my mouse hand as well. So I'm going to set my accept and cancel buttons right away too. So clicking on my form, scrolling down to my properties, I'll pick my BTN submit for my accept button, and scrolling down to cancel button, I'm going to select BTN exit. Now those don't do us any good until we actually have some code, so double clicking on exit, I'll generate my exit button click, and I'm going to say application.exit. I have enough to test my program out. When I start debug, hitting the enter key doesn't do anything yet because we don't have any code, but hitting the escape key will now close my application. And I see that I still have that default placeholder value. So I want to clear that out of my form load. Going somewhere that's empty, double click, will generate my form load event. And I'm going to say lbl message.text equals quote, quote, semicolon. Starting it again, I can see that's cleared out and everything else is ready to go. What we want this program to do is we want to be able to have a user click on our text box and type in a number. When they type in the number and hit submit, I want to see the value of this number displayed here but double. So in this case, this should display 112 when they click submit. But we have a couple steps and a couple things that we need to talk about before we get that far. I'm going to double click on my submit button so we have some code to work with, and so we can start typing some things out. Now, if we wanted to, we could run this program, and when they type in 56, we could click the submit button and we could in fact display 112. We could cheat and sort of make it look like the application is really doing what we think we're doing. So if I wanted to go into the text box and I'm going to type in 56, and that's going to be there when they launch the program the first time, and then going into the submit button, I could type in lbl message.text equals, and whereas before we've said things like hello world inside of my string here between two quotes, I could type this instead, 112. Running my program, hitting submit, and it looks like my program's doing exactly what we think it does. And maybe we hope that they'll close it down and they won't try anything else. But we all know that if they change the number, it's still going to do the same thing. So we need to be able to do some sort of math in here. And not only that, but we have to be able to get the user input, do the math, and then output it back out. But in order to do that, we have to work with the value that's in here. And if we really wanted to work with 56, we have to be able to somehow work with that value. And working with values requires that you put those values inside of some sort of container. In this case, our containers are called variables. And they're called variables because the values themselves can vary. Think of it as a cup. And in that cup, you could put water, you could put soda, you could put coffee. Those are all different types of liquids that that cup can hold. Think of that cup as a variable, and think of something like coffee or soda or milk as the values that belong in there. And it's variable in that we can decide what we put in there, and then we could turn around and we could put something else in there instead. Variables also have the concept of data types. So there are certain types of variables that hold certain types of data. So for example, you can have a cup, and the cup can hold a liquid. But you would not want to put something like a book inside of a cup, right? And it does sound sort of like a strange example, but what would you put a book in? A box or a backpack? A box or a backpack would not be a suitable container for a liquid. So different variable types hold different kinds of values. In our case, what we are really familiar with working with so far is pieces of text. And we're talking about anything that we've been displaying in a message label like this. And we know that when we want to work with a piece of text, we do a start quote, the value, and then an end quote. And something that we've been working with would be a piece of text like hello world. Well, this particular type of data is called a string. And so when we wanted to make a string variable, it would have to be a particular type. And so this is how we declare one of these containers, one of these variables inside of C#. We first start with the type of data that it is. In this case, it's string, so we type out the word string, and you'll notice that it turns blue. And blue inside of C# and Visual Studio, and you may have noticed this already, but it has a special meaning behind it. We would say that this is a keyword. It's also a reserved word. You can't use the word private or void anywhere else in your program unless you're doing it properly like this. And in this case, string is a special keyword. The next up is we want to give it a name. Just like we've been giving our controls, like our labels and our text boxes and our buttons names, variables also have names. And that makes them unique across the whole program, and we can access them via code as well. We're also going to use naming conventions with our variable names. Naming conventions for variables are tied directly to the type that they are. So in this case with string, we do str, and then we'll do a good name that describes something about it. So in this case, I'm just going to call this one str hello. And you'll often hear me refer to this as string hello. I'm not going to attempt to pronounce str hello. That doesn't make much sense, and it certainly doesn't come off the lips very well. So I will refer to this as a string hello. But the actual typing of it is str. Next, I do my equal sign, because I want to set the value of this variable to equal just what I'm doing in the line above. I'll do capital. And it looks very much like how when we set a value for a label. The container goes on the left-hand side, the value goes on the right. Now you're going to get a squiggly. If this was normal visual settings, it would look green. And it gives you a little warning message. It's not an error. If we were to try and build this, it would build. But it gives you a warning, and it says, the variable string hello is assigned, but its value is never used. And it's kind of letting you know that you have a variable that you haven't done anything with, so you might not really need it. But for right now, we're just going to ignore this because we are going to use it, or we wouldn't do anything with it instead. Now what we can do with this variable, the variable that now contains the value hello world, is, whereas before we would have done something like this, which you're seeing, and actually I'm just going to move this line here. I can highlight it, and I can hold down my left mouse button and drag it down. What we were doing before is we were saying lblmessage.text equals the actual text hello world. Now I can take this variable and put it there instead. So dragging over this and hitting my delete key, I'm now going to type str hello. Because this variable contains hello world, the label message is going to receive that value now as part of its text property, and it's going to run just as if it would before. And so the word that I'll be using a lot is this variable evaluates out to this value. Now this is a string variable. We would say this is a string data type, and it's going to be capable of holding text. But there are other variable types as well. And so we need to kind of examine, well, what are the different types of data? And if you step away from the whole idea of just C#, think about the kinds of data that you work with or that you talk about in the real world. Well, one of them would be numbers, right? Someone has an age. You have the amount of credits that you're enrolled in this semester. Numbers would be like 1, 2, 3, 4, 5, etc. But we also have the idea of numbers that have decimal points on them. So what do we do with numbers like 23.4 and 67.3? We say it has a decimal point. Well, these are actually split into two different groups. We have whole numbers, aka integers, which are 1, 2, 3, 4, 5, also -1, -2, -3. These are whole numbers, as in they don't have decimal points. Then we have decimal numbers, aka we say that those are doubles. So we have numbers like 1.1, 1.2, and then also you can say -1.1, -56.7, for example. We have our strings. So we have things like hello, or Betty, or Tom. Those are words. Those are letters. Those aren't something that we would consider a numerical value. And then we also have something called a Boolean, which is saying true or false. And we'll talk more about what those are used for. But these are really the basic data types. And so we can declare variables of these types, and part of it is knowing, well, which data type do you use in which situation. Well, from our application right now, we want to talk about a number, right? And so we could, if we wanted to, have the value 56 in a string, right? So we could say something like this. We could say string str number equals 56. Oops. But if it has a quote around it, think of this as this is the word 56. This will not work with math because strings are just pieces of text. If you want to do math, we need to work with numbers. We need to work with one of these number types. So since we're talking about numbers, we want to work with an integer, which is what we talked about right here. And an integer, defining it in C#, looks like this. int, and then we have to do our 3-letter prefix, and it just so happens to be the same thing, and we'll say int number. And so this looks much like how we did with string, but instead we'll say equals sign, and because it's not a piece of text, because it's not a word, we can just type 56 directly like that. And again, we're still going to get this squiggly line underneath. It says the variable int number is assigned, but its value is never used. That's because we haven't used it yet. And so now that we have an integer variable, we can actually do things with it. We can do things like add something to it. We can multiply it. We can divide it. And that's what's great about these numerical data types, is now we can actually do math with them. And so I can have something like this. If I wanted to, all in one line, I could say 56 plus 10, for example. And what will happen is it will declare this variable, and then it will evaluate what this statement is. And we can all tell that looking at it, it's 66. And while the code runs, it will add these two numbers together and place the result in this variable, in this container. I can also declare multiple variables. So I could say something like int total. And I can say this one is, again, maybe 66 plus 10. And so you're capable of having multiple variables out here. And one thing we need to look at is, well, in this situation, we declared a string, and that string said hello world, and then we used that variable to set our label. Any place I could use this, which represents a string, which evaluates out to a string, I can use a variable of the same type. So if this one turns out to be 66 and the value goes inside of this variable, and I have the number 66 here, I can actually use this and switch it out. So deleting that 66, I can type in int number plus 10. And you'll notice now that goes away because I'm actually using my variables. And so again, we would say this evaluates to 66, and then it's as if it's really saying 66 plus 10, which is 76, and that will go into our total there. And so we can use variables in place of what we would call hard-coded values. And we say hard-coded because no matter how many times I run this program, this is always going to equal out to 66. But what do we want to do? We were talking about taking our number and multiplying it times 2. So I'm going to delete this 10 because we wanted this to start initially out as 56. And here, we didn't want to add 10 to the number, we wanted to multiply it times 2, because that's what doubling a number is. So here, I'm going to get rid of my plus sign, and I'm going to type asterisk, because that's how we do multiplication. There's no x. X actually would mean something else. I'm going to do an asterisk, which is shift 8, and now I want to multiply it by 2, so I'm going to say 2. And now int total will contain int number multiplied by 2. So we're a little closer to where we need to be. Right now we have this value. It's multiplying 56 times 2, but we don't really have any way of proving to see if it works. In fact, when we hit submit, we're still saying hello world. So what we want to do is, instead of displaying hello world, I want to display the result of that multiplication. Now, with what we did up here, we say, okay, we have a string, hello world. We're taking that string variable and we're using it to set the value of our label message.text. So we should be able to do the same thing here, but instead use our int total. So now I'll say lbl message.text equals int total. And we get a red line. And we all know that when you get a red line, that means there is an error. But let's take a look at the error. And it says, cannot implicitly convert type int to string. So we've had strings living off by themselves, and we've had integers kind of doing their own thing here. But now what we want to do is text expects string value, and integer, well, that's a numeric value. That's int. We have two types that can't get along. And this is a thing with programming in general, is that when you want to change one type over to another, you need to do a conversion. And when it says cannot implicitly convert type, what it's really saying is it can't guess. It's saying, I don't know if this is really what you meant to do, but I'm going to tell you that I can't guess on what it is that you want. So we have to do a conversion from one over to another. And so, to get an integer to a string value, it turns out that the .NET framework has built in several things that can help us with this. In fact, on an integer, it's extremely easy. So you go at the end of your variable name and you hit dot. Just like we would do txt number dot text, we can do int total dot, and we see what methods are available to call on this integer. And the one that we want is toString. That one's easy to remember, is that it will actually convert it to a string. So double clicking, and because it's a method, I need to put open parentheses, close parentheses at the end. And now, if I build, it will get rid of my error message. So let's run it and see what happens. Start debugging, and clicking, and there, sure enough, it doubles it to 112. So we can see that it really is doing some math for us. We have 56 here. We have int number times 2, which will double 56. It puts the value 112 inside this variable. And then lastly, we're taking our int total and using it to set the display on our label. If I were to try 50 though, well, it's not quite dynamic yet. It's not depending on our user input yet. So why? Well, because we've hard-coded this value here. This is what it's getting its display from, but we've hard-coded the value 56 into it. So what we have to do, and this is our last piece of the puzzle, is we need to figure out how can we get what's in this text box into this variable. Let's look to see what we did in the input mirror program when we wanted to get input from the user. So on button submit, we wanted to take what was in the text box and put it out onto our label on our form. So if I said hi there and I hit submit, it took what was in the text box and put it in the label. The label was on the left hand side, the text box was on the right. So we should be able to do the same thing, but instead of a label, we should be able to put a variable here instead. So going back into my number program, let's see what we can do. I have int number here, and I hard-coded that to 56. But if I want the user input instead, I should be able to say txt number dot text. It should take the value out of my text box and put it into my integer. But I see that I'm getting a red line. So let's see what the error is. I'll hit build. And you can mouse over the error, or you can go into your error list that pops up. And again it says, cannot implicitly convert type string to int. Well, we've already seen that. But before, the message was flipped around and it said, cannot implicitly convert type int to string. So now we have it going back the other way. And how we solved it last time is we said int total dot toString. So we would hope maybe if we went to the end of this and we said dot, just maybe there might be a to integer. But there's not. And there's a whole bunch of things that says to list, to lower, to array, to char. That's nothing that we need and nothing that we can use. So we need again to rely on the .NET framework for this. We want to convert what is a string, because it considers anything the user types to be text. It considers that to be a string. We need to change that over to an integer. And so .NET gives us a helper library. I will type this in front of, give yourself a space in front of your text box and type convert dot to for to, and then int, and then it gives us three options: to int 16, to int 32, and to int 64. These are different size integers that we'll talk about. The standard integer that we've been using is considered to be a 32-bit integer, and that's the one that we're going to pick. I'm going to hit tab, and now we have to do this because it is a method. We have to say open parentheses at the start of our text box, and then at the very end, after .text, we have to say close parentheses. And we would say that I'm passing this value to my helper function, to my helper method. Often I'll think of this as the conversion is opening up its mouth and it's eating our text box. And then when it's done, it spits the number back out. However you want to help you remember, that's how I remember it. So now, what it did is it took this text value and it converted it to an integer, and then we would say this all evaluated out to a number that's being stored in this variable. Going to start, type in 56, hit submit, that worked, and now the moment of truth, type in 50, and that worked. Type in 20, that worked. Type in 999, and that has worked. So we're getting the value from our text box, storing it in a variable, using that variable, multiplying it times 2, taking that result, putting it inside of this variable, which is our total. It's going to hold our total value, and then finally use that total, convert it to a string, and put it back out to message. So we really learned quite a few new things during this lecture. In other languages, such as Visual Basic.net, a lot of the conversion, the implicit conversion, specifically, it will guess for you. But it turns out later that you don't want it guessing for you, and sometimes that can get you into trouble. So we like to be able to have the control to tell our code specifically what it is that we want it to do. And so almost every single application is going to go along the lines of declaring your variables, getting the user input, doing the calculations, and then lastly, displaying it out to the user. In order to do math on a value, it has to be in a numeric value type. We can't do math with strings. And then when we're done with it, we have to convert it back to a string because that's what the user interface expects. Now, as you're following along and as you're writing this code, you may accidentally type in some values. You may have no values at all, or maybe you'll do something like 56V accidentally. Because .NET is trying to convert this value to a number, it's not smart enough to say, well, I can see you put a 56, but the V must have been an accident. And you're going to hit submit, and your program is going to crash. And you'll get this yellow bar. You'll get a big message box up here that says there was an error. And this is okay. That just means that it didn't get the number it was expecting. So if this happens, you can go up to your debug menu and say stop debugging, and that will get you back out. And we will be talking about how you convert and how you check for appropriate user input. But for right now, if your program crashes on bad input, that is okay.